We're going to learn how to solve systems of equations this afternoon, and this time we're going to learn how to do it by linear combination. All right, linear combination. Now here's the thing, it's the same thing that we've been doing. We want to eliminate a variable, and I want you to look at these y terms. I have a 6y here and a 3y here. If you remember in our first talk using the elimination method, sometimes we had to multiply by -1. Well, look, what if I multiply this equation by -2? If I multiply the entire equation by -2, well, then I have -4x minus 6y equals 10. And if I just bring the top equation over, 5x plus 6y equals -8. Well, look, now I have opposites here. And if I add these two equations, we eliminate a variable. The y terms disappear. 5x plus -4x is 1x. -8 plus 10 is 2. So x equals 2. That's the x coordinate of my solution, but remember, I need an x and a y. So I need to plug this x back into one of the original equations. I'll use the top one. 5x plus 6y equals -8. So I'll put this 2 in right here. 5 times 2 plus 6y equals -8. And now we can solve for y. So I have 10 plus 6y equals -8. Doing our basic algebra steps here. Subtract 10 from both sides. I have 6y equals -18. Divide both sides by 6. And my y coordinate of the solution is -3. Remember, the whole goal is to find a point of intersection from these two linear lines. And so now I have a point, 2, -3. Now let's look at one more example. Let's say that we had 4x plus 2y equals 8. And I'm looking behind me at my notes page. 3x plus 3y equals 9. Now, our goal is still to eliminate either the x or the y variable. So in this case, I'm going to have to multiply both equations by something to get an opposite. You know, up here we had a +6 and a -6. So here I've got a 4 and a 3 to choose from, and I've got a 2 and a 3 to choose from. How about we get rid of the x? So if I'm going to get rid of the x, I need to multiply one of these by a negative number. So I'll multiply the top one by -3, and I'll multiply the bottom one by +4. That way I get opposites. So if I distribute this multiplication through, I have a new equation of -12x minus 6y equals -24. The bottom equation, when I distribute the multiplication with the 4, I have +12x plus 12y equals 36. And now I have my opposites right here with the x's, so that I can add these two equations and follow the same process. The x's disappear. -6 plus 12 is 6y equals 12. -24 plus 36 is 12. Divide both sides by 6, and I have my y coordinate of my solution, and I plug it back in. I'll use the bottom equation this time, 3x plus 3y equals 9. Plug this in for y. By the way, sometimes people ask me if I could use either of these two equations up here. And the answer is yes, they're the same equation, because all we've done is multiply them by a factor on both sides of the equal sign. So you would still get the same thing, but I don't know why you would do that, because you're working with bigger numbers. I'd rather work with the smaller numbers. So plug in your y, 3x plus 3 times 2 equals 9. 3x plus 6 equals 9. Finish solving it. 3x equals 3. Divide both sides by 3, and the x coordinate of our solution is 1. And we will stop there for today. Thank you for joining.